thing, the possibility of getting the thing, the possibilities of happening occurrence. The specific amount would happen if an event were repeated. Specific outcome. It may be if you are throwing a coin, right, and throwing the dice, anything. A specific outcome would happen if the event were repeated a very large number of times. This is the thing. In other words, the probability of the occurrence of an event is the ratio of the number of times the event occurs to the number of times it. See this, where it will come, the ratio is defining nicely. How many times it may happen, how many times we will do that. These two words are very important. Occurrence of an event is the ratio of number of times the event occurs. Okay. How many times the event will occur? Let us say now we are probability like the toss of a coin. The probability, if you see the toss of a coin, if we toss the coin and the number of times the event occurs. See, I'm telling, if I want, I toss a time, I toss off a coin, getting a head. How many times I'm thinking of? One time. To the number of times it. When I throw the coins twice, the chances of getting, or one time if I take one, the chance of getting a head is 1. Right? Definitely the chance of getting a head is, we cannot say 2. 1 divided by how many options are there? Head and the tail. Now, we can see if an event can happen in A ways, fail to happen in B ways, and except for the numerical difference, even is like to happen is to fail. The mathematical probability is for happening A by A plus B. Happening or not happening, or A plus B. If I am throwing, say, A is called happening, B is called not happening, and the probability of getting happening is happening denoted by A by A plus B. Simple. Now, it's not happening, failing, denoted by B, B by A plus B. Dictionary of Science, ELBS publication. For example, say there are 2 possibilities in a toss of a coin, getting a head, not getting a head. Therefore, the probability of getting a head is what? 1 by 1 plus 2, 1 by 1 plus 1. And not getting a head, again, this is getting a head 1, not getting a head 1 will be on the top. We have 2 things, getting a head and not getting 1 by 2. Thus, the probability is a numerical value that measures the uncertainty of a particular event occur. It will ranges from 0 to 1. You can say 0 or 1. 0 for an event which cannot happen. 1 for an event which surely to happen. How the number is assigned would depend on the interpretation and approach to probability. Importance of the concept of probability. Today, the theory of probability has been very extensively developed, and there is hardly any discipline, science, whether physical or social. We know that the importance of the concept of the probability, because this is a science actually. In the social and the physical, where it is not extensively used in the field of business and economics. It's very widely used for quantitative analysis for various problems in forms of modern theory of decision making. Actually, in the today's modern days, in the decision making process, these probabilities using it is successfully applied at the gambling tables, starting with the games of chance, whether they will win or they will lose. Solution of social, economic, and etc. See, this theory, you can read it. Another thing, and see, these terminology is also important to understand about the probability. Random experiment. Experiment is an action or an operation which can produce any result or outcome. Tossing a coin is an experiment. This is the called experiment. The term experiment is used in probability theory in a broader sense by random experience. all the outcomes of an experiment known in advance. This is the thing. We need to understand that the outcomes of an experiment, we will know that either that or this it will happen, but it will happen. The number of outcomes are at least, example, in case of toss. The outcome of experiment cannot be expected in advance. That is, there is uncertainty about outcome. Example, in case of tossing a coin, we don't know whether we are going to head or tail upwards. Experiment can be repeated any number of times as one likes under identical conditions. Anything, you can toss it, you can do a trial, whatever, you can check it for that. Okay. In a case, a fair die is collected. A die has 6 faces. We know the die, right? 1, 2, 3, 4, 5, 6. It is known that maybe the possible outcomes will occur, but it is not known exactly what the outcome will be. That is important. The die may be rolled any number of times. Rolling a die is an experiment, or tail, or getting 1 or 2 is an event outcome. See, experiments dying. What is that? Die, rolling. Okay, the word rolling a die is an experiment, and or a trial, and getting it may be 1, the face. We know that, right? 6 faces, yes or no, in a die. Hello, are you all there listening? Kalyan, Vinod, you're responding.
Yes,
Aviram, yeah.
yes, sir. Following, sir. Following.
Okay, thank you. Right, the die will be there. There will be 6 faces. When I do an experiment, that's now I said, when I rolling and I die, any phase will occur, and that events, any phase will come. No, when I roll a die, phase will come. Those occurrences or events, we call it as those things we call it as an event or an outcome. It may come as 1, 2, 3, 4, 5, 6. Getting an odd number or getting an even number is a composite event. You need to understand. A composite event means, like I say, any number will come 6 times. If you roll, any number will come. Right? 1 may come all the 6 times. 2 may come all the 6 times. Or one time 1 will come, second time 2 may come, 3 may come, anything may come. Event. Any single outcome of an experiment is an event. Outcome of an experiment is an event. Getting a head or a tail. Tossing a coin, experiment. Event can be simple or a composite, also called as compound event. Composite means it may be odd or even, like that. Some regular thing other than the regular thing, we will think in a different. Next one, sample point. Sample point of the outcome of the result of a single trial or random experiment is called an elementary outcome or event or a sample. Sample space. The totality of all the sample points is known as the sample space of a random experiment. Instance, in a coin tossing experiment, there are 2 possibilities, assuming that the coin will not stand on its edge. This will be there, right? Getting a head in a single tail is a sample point. And the totality sample points is head and tail together, constituting its sample space. Similarly, in rolling a die experiment, how many will be there? 1 to 6 constituting the sample space. This is how many times it will happen. Random event, if chance factors alone determine its outcomes. Equally likely events. Outcomes are said to be equally if none of the outcomes is expected in preference to others. In other words, the possible outcomes are having equal chance to happen. Right, equally likely events. It may say how many chances there will, if you toss a coin to get a head. The same kind of events may also happen, right? Maybe in related to the tail. In anything can happen. Right? Mutual exclusive. 2 more movements said to be if the occurrence of any of them is single train precedence or exclude the occurrence. In other words, the outcomes cannot happen simultaneously in a single time. Right? One after the other, it may not happen. So the occurrence of any of them excludes the occurrence of all others. When it is happening, one tile is getting, other thing may not get it. Mutual exclusive, exhaustive events, independent events, dependent events. We need to understand the two events are said to be if the occurrence of the first outcomes does not affect the occurrence of second outcome. Dependent events. This is important. Does affect, not does not, does affect. All right. For example, the prices are increasing now. Let us say. Because the prices are increasing, again, the sales will go down. Let us assume. These are called dependent events. Price and the sales. Price and the sales. This is important. There are 4 kings in a park for 20 minutes. Right? This is the thing. Okay, let's go into the thing. Complementary events, favorable events. Let's approaches to the probability. This is the thing. There is a classical approach. There is a relative frequency approach, subjective approach, and modern exercise. So I will just explain the formulas because we have 2 more units to complete now. Classical approach. The number of favorable cases to A, exhaustive number of cases, or total number of equally likely cases. This is important. Called as mathematical or probability. It had its beginning with games of chance. And it's still most often discussed in this term. The prior mathematical and classical probability may define as this. Say, if out of n exhaustive, mutually exclusive, equally likely outcomes of an experiment, m are favorable to the occurrence of an event A, then the probability is A is defined as m by n. That is the probability of A occurring is number of favorable cases to A divided by exhaustive number of cases or total number of equally likely cases. This is classical approach. P of A is equal to probability of A occurring is small m by small m. The ratio of the number of favorable cases to the total number of equally likely cases. How many favorable will come? Divided by equally likely cases also. We need to come down. Now, it is also priori probability. Why it is? Pure deductive reasoning will be there in that. For that, we need to calculate. The answer is similarly the probability of non-occurrences, number of favorable cases to A bar divided by total number of equally likely cases or exhaustive number of the cases. See the solution. In a college lottery, there are 2 prizes and 98 blanks. One student holds 1 ticket. What is the probability that the student is getting a prize and not getting a prize? Tell me how many prizes are there?
2 prizes, sir. First and second.
2 prizes are there. And the total number of tickets, see, there are 2 prizes, 1 and 2 are there, and there are 98
tickets.
98 blanks are there. Exhaustive cases, all cases together, how much? 98 plus first prize and second prize, right? I mean,
Yes,
in other words, in the lottery, 100. Total number of favorable cases for getting a prize is 2. Of course, under 100 are there. Total number of favorable cases, if you take 100 chits, but the favorable cases are getting prizes, only 2 we have. Number of unfavorable cases not getting a prizes other than the 2 chits, if you take any chit. So like that, how many we have? 98. Now they're asking us to calculate getting a prize. Now, when you're getting a prize, always remember that actually chances of getting a prize, how many are there? 2 are there. Total number of chances or the total number of events, how much? 100 are there. Now, if they say like the probability of getting a prize is definitely 2 by 100. In 100, 2 are there to get a prize. This is the probability. Not getting a prize. Hello? Not getting a prize, how many chances are there? Out of 100, how many chits are empty? 98 chits are empty.
Yes, sir.
98 chits are empty. Overall, how many chits are there? Okay, let us say that lottery ticket or whatever. I'm using the word chits, whatever. 100 are there. 98 by 100. Now see, favorable events, that means getting a first and ranks or not getting a thing. See, down the numerator will be the same. You need to first understand the down, anything we are calculating out of the whole. The whole events are 100. Getting a chance is 2 by 100. Not getting a chance is 98 by 100. That's it. Yeah, this is called the favorable. The Q is represented by failure. That is unfavorable event. We'll call it as a Q. Favorable failure. The chance of getting number 4 in a single throw of a die. The chance of getting a 4 in a single throw of a die. I just throwed a die. Chance of getting 4 is how much?
1, sir.
1. Okay, let's
Yes,
see. Die has 6 faces. We know that, right? When it is thrown, we will get only one number. That maybe it may be the 4 or 8. All the equally likely and mutually exclusive. Why they are using word equally likely and mutually exclusive? See, like 4, other number also having equally likely and mutually exclusive. The probability of each item is 1 by 6. Because if we thrown, we will get only one number. Say, we are not writing 4 by 6. We are not talking about 1, 2, 3, 4, 5, 6. We are not talking about the numbers which are there on a die. Don't confuse here. Here is asking die is thrown. Look die as a die. It's not a, the office or whatever. Die as a die. It won't give you any recommendations. It won't talk to you or anyway. But for that die, there are 6 numbers there. And when you throw the die, get only one number. This is, since all the equally likely and mutually probability of each is 1 by 6. Very simple. Getting a 4. You now tell me, getting the number 4 in a single throw is 1 by 6. Now, what is getting a number of 6 in a single throw? Number 6.
1, sir. 1, sir. 6 by 6. No, sir. 1 by 6.
1 by 6. Yeah. Unfavorable events is the 1 by 6. The probability of Q that is not getting 4 is total number of unfavorable B events is 5. Total number of equal events is 6. This is the thing. When I am talking about the probability of Q that is not getting 4. Is not getting 4 means here chance of getting number of 4 in a single window is 1 by 6 because only one chance is there. For not getting 4, how many chances are there?
5 by 6.
5 chances are there. And total how many likely events are there? 6 are there.
6.
5 by 6. This is the thing. You need to think nicely here, then only you will understand this. Now, a bag contains 13 blue, 20 green balls. A ball is drawn at a random. See, there are two color balls are there. A ball is drawn at a random. Random is, I kept my hand in that random. I draw the ball. What is the probability that is a blue ball and a green ball? Can anyone guess? Just I am not showing you here. Can anyone do here? How many balls are there together? 30 balls. Out of 30 ball, a ball is, what is the probability that a blue ball and a green ball? Right. Number of favorable events, how many? Total number of equally likely events or exhaustive events, how many? Say equal likely means they are asking about a blue ball or a green ball. It is when you're talking about a blue ball, it is same with the green ball as well, right? When you keep a hand in that bag and if you take it. Now the probability that a blue ball is definitely 10 by 30. Yeah, because we have 10 chances of getting it is there. But total balls we have 30. The probability of getting a green ball is definitely we have 20 way chances are there to get a green ball, 20 by 30. This is how we need to calculate. On the same analogy, what is the probability? Is not. See, 10 balls are there. How many are not blue balls? Out of, what is that? 30 balls.
20.
20 balls are there. Then it should be unfavorable events. Remove the 10 blue balls. Because 10 blue balls we don't want. That's what they're asking. Not getting means getting 10 chances are there. Unfavorable event definitely. Other than the blue ball, such thing you need to mention the green ball, 20 by 30. But number of balls are not changed, but not getting 20. The similarly to the green ball, not getting means 10. In 10 cases only, you won't get the green ball. Say this talking, it will easy, but you will get it. This is how we will calculate. Can anyone try this? Okay, just see the recommendation. I mean, answers are there. Okay, let's see this also. It's looking a bit quite different. Yeah. I'm sorry. Okay. The doctor performed 200 surgeries, of which 190 are successful. What is the probability? What is the probability that a surgery to be performed is a success? Probability that a surgery to be performed is a success. We know that surgery performed is 200. Total number of successful is 190. Total failures are 10. That is very clear. Therefore, probability of success of a surgery is what? Successful surgeries are 190. Simple. Total surgeries 200. There is
200.
200. Next. Probability of failure of a surgery definitely
10.
10. Yeah. By 200, you will get 0.055. Okay, like that you can also answer all these things. Subjective approach. For a job vacancy, this is axiomatic approach. Different. Okay, let's see the subject. For a job vacancy, 10 candidates appeared for an interview. What is the probability the post will go for Mr. X? Tell me quickly. Whether it is X or Y or Z, post will go for any one out of 10 is 1 by 10 only. Very simple. And see here, in this case, this is about an interview. They may reject 10 people also, right?
Yes, sir.
Yeah, but in these cases, we have not done well too. The job will definitely come to me because I have done very well. 3, the probability is 1 by 10 as all are having equal chances of getting a thing. 4, he may assign any other number between 0 to 1 based on his experience and information with him. In these cases, we can't calculate because this is all based on the skill based. We are not randomly picking up. We are not keeping hands on anyone's head to understand that concept. Okay, this we need to understand. Axiomatic approach, just if you go through this, you will understand. Now this is important thing. Now, axiomatic approach. This modern probability is based on the axiomatic approach introduced by the Russian mathematician, which is considered to be a classic modern blah, 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 concept of both the classical and empirical definition. In this approach, no precise definition of probability is given. They didn't give anything. Only certain axioms or requirements on which probability calculations are based are given. For example, axiom 1, non-negativity, that is the probability of A is real and non-negative is PA greater than or equal to 0. Getting a sample space is 1, PS is equal to 1. Okay, the probability of an impossible event is 0 and the probability of a sure event is always 1. Impossible event will be there. So the probability range is between 0 and 1. The axiom of additivity. If A and B are two mutually exclusive events, then the probability of occurrence of either B or is denoted by A union B. This is important. A union B.
I forgot. It is same
Um,
It's raining. It's on the white bus.
yes.
It's raining.
Oh. Okay. The axiom of additivity that we have seen P A union B is equal to additive, pronounced as probability. A union B is equal to P of A plus U is union A or B. Basic sets. What is set? Defined collection of aggregate or objects having given properties specified according to a well-defined rule. Ambedkar University Chief Minister of TS cards in a club, bunch of numbers, all are sets. The object comprising the set are known as elements. Sets are usually represented by capital letters, that is A, B, C. Null set. A set having no element at all is called a null set, denoted by phi. Universal set denoted by S. Unions of set A union B are defined as set of elements. This is the thing. A union B is equal to B union A, combining. Intersection of sets. When both are intersect each other, we call it as an A intersection B. We know that, right? Combined together in the intersection B. Do you all have some basic knowledge about this? Shall I go a bit fast?
Okay, sir.
Yes,
Yeah.
sir.
Because we are not able to just cope up with this. Complementation of sets. The complementation of set A usually denoted by A or A dash or A power C is a set of elements which do not belong to the set A. Okay. But which belong to the universal set S. A shaded region is FC. Two events A and B are mutually exclusive, disjoint. That is, if they do not have any common point, A intersection B, because there is no common point. Additional theorem of mutual exclusive P of A, P of B, that is, this is already discussed. The probability that the RAM will get selected A. What is the probability that Sham will selected B? What is the probability that either RAM or Sham will be selected B? For 5 equally capable students have appeared for an interview in a company that has only one vacancy. The group consists of Ram, Sham, and others. If one question is that probability of A is 1 by 5. Anybody, either it is Ram or Sham. Probability of B, Sham is how many jobs are there? 5. 1 by 5. Probability of A or B. A or B is A union, right? A or B. A plus B. 1 by 5 plus 1 by 5 is equal to 0. This rule, when extended to 3 or more, also the same thing. 1 by 5, 1 by 5, 1 by 3 or more also we can. A card is drawn from a deck of 52 cards. We know that, right? In 52 cards, we have a deck. We call it as a deck. It is a set. That's what they're calling. What are the probabilities? Either an ace or a king or a queen. How many aces will be there in a set of 52 cards? Hello?
4, sir. 4, sir.
Ma?
4, sir. 4, sir.
4, right? 4. We know that every deck consists of 4 each of his. King will be 4, queen will be 4, ace will be the 4, 4, 4, 4. Definitely ace 4 by 52, king 4 by 52, queen 4 by 52. Now combination. Either an ace, king or a queen. Say or. Means you blindly you can
Uh,
make it as
4 by
individually.
52 plus 4 by 50.
Amma?
Yes, sir. 4 by 52 plus 4 by 52 plus 4 by 52.
Yes. Or means you need to tell
12
union
by
or
52.
like plus, 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 plus.
Yes.
4 by 52, 4 by 52, 4 by 52. You will get the answer. Next, this one. Heart on a dice, single draw from a deck of 52. Hearts are 13 cards, including one ace. Aces are four including one heart ace. Out of 52, there are one heart, that is 1 by 52. Now the probability is drawing a heart or an ace is this by this by this by this. Bus. And but they're asking another thing here. P of A. P of A or B is equal to P of A plus P of B minus P of A. Why we have taken the formula? The hearts are including one ace. Aces are 4, including one heart. Out of 52, there are one heart ace, that is 1 by 52. Now the probability is this 13 by 52 and this. Okay, all the things will be like that only. This is some multiplication theorem. Yeah, here we need to. A intersection B is called P of A into P of B. Same thing. If it is individually, we can individually. If they're asking together, into. Okay, the rule can be extended to more independent variables. There are some extensions. 5 green balls, 7 balls, 2 balls are drawn. What is the probability that one of them is green and other is red? You know that probability of drawing a green ball is 5, red ball is 7, and probability that one of them is green and the other is red. Definitely here into we need to use. This logic we need to understand. Where we are using PA plus PB plus. Why we are using it to here? Yes, ma.
A intersection B. P of A intersection B.
A bit louder. What you said? Hello. Right. This is the story. Green, red ball is this. Simply we can write this 5. Drawing a ball into we need to use because one of them is green and the other one is red. One of them is green, other one is red. We want both the things. You need to multiply both. There are 60 articles in a box which are 20 defective, 40 are good one. If the sample of 2 is drawn at a random blindfold, probably getting 1 defective and other one is good. How to do? 1 defective, 1 see. When we are combining both, when we are talking individually, the answer will be different. When we are combining both, the answer will be into. You need to remember. 20 defective, 40 good is 60. A and B, P and T is 20 by 60. That is 60 into we need to do. You will get the answer. The same thing you can apply to all these things. Bayes theorem is also important to understand. Let's see directly go through the sums. Okay, let's see the formula. Formula for conditional probability. If an A can occur in conjunction with one of the n mutually exclusive and exhaustive events. If A actually happens, then the probability that it was preceded by the particular event is E1, E2, E3. This is how this is the formula. And this is the formula they have given. Mutual exclusive events, E1. I is equal to I, the event say 1, 2, 3, whatever. And another event which is preceded by an event EI. Probability A and probability EI is known. Then the probability of EI given that it is A is given by, this is the formula. Now let's see the example directly, quickly. In a bolt manufacturing company, there are 3 machines, M1, M2, which produce 25% of the bolts. As per records, it observes 5% of their output are defective bolts. How many bolts they are producing? Clear. Out of that, how much percentage is defective? 542. The bolt is drawn at a random from output and is found defective. What is the probability that defective bolt produced by mission I? Pretty complicated. Right? What is the probabilities that are produced by mission 2 and mission 3?
Amma function.
Yes, nice.
No, Amma function.
Yeah. Plus objective. Let A be the defective bolt, EI. Be the event. How many event drawing from a bolt? 3 events, right? E1, E2. Mission on to next. From the first information, the prior probabilities of the defective bolts are proportion of their output. That is 25, 35. Therefore, the probability of defective bolt from mission A to 3 should be P of E is equal to 0.25, P of E is equal to this, P of E is equal to this. This already we calculated. But from the observed information, the probabilities of each mission producing defective bolts is P by A by E1 is 0.05. What is P of A? Yes, ma'am. What is P of B? Sorry, P of E2? That we need to understand here. When it is defective bolts are there, I am using that. Then EAI is equal to 0.05, 0.04. So you calculate with this, you will understand. 2. PC. Conditional probability of observation A by 3 is 3. Probability. Illustration 2, just go through it. Arithmetical expectation, already we have seen few sums here. If there are any villas, I will just see. For some formulas. Okay, let's go into the next chapter quickly. We have few minutes. Discrete probability distribution. Tomorrow is also easy topic to understand. Don't join late. Tomorrow also it is about the hypothesis testing and this. Okay. Let's go into that directly. What is random variable, theoretical distribution, and binomial distribution and Poisson distribution. Let's directly go into the what is what, and directly I'll go into the binomial and the distribution. Random variable is the numeric quantity whose value is determined by the outcome of the random chance experiment. The experiment is performed. The total volumes of experiment set of is called sample space. All total occurrences, S big one, that we have seen in the Venn diagram. A random variable take different values as a result of the outcome of a random experiment. We know that when we are experimenting something, output will come certain. When a die is thrown, assume that value on the top is all 6 and sample space 6. Simple. The random variable can be either discrete or continuous. Random variable is said to be discrete if it takes only finite or countable number of individuals. Finite, you remember that. Continuous random variable. These are the things: age of an individual, time and take by the doctor, number of hours beginning, burning, life on electrical. Expected mean of a random variable. Here we have probabilities. The possible waste which contain TT1 probability distribution. Listen to this carefully. Possible outcome that if the experiment is performed. In other words, a table listing all possible values that a random variables can assume. 6, 1 by 6, 1 by 6, 1 by 6. We know that 6 by 6 is equal to 1. Always P of X is equal to 1. All together. Right? The table listing of all the possibilities can assume whether the probability mass function. Random X is equal to number of its face. Simple. When you die for it's equal to X. If 2 coins are tossed, the probability of getting 0 head, 1 head, 2 heads are as follows. Which the contains may fall or TT, TH, etc. Tail, head, all, etc. 2 times 2 heads at once. See, this is how they have written. Number of heads. Here is F Probability is 1 by 4. 1. So 2. 2 by 4 is next one. Expected value mean of the random. The expected value, that is the mean of the random variable, is sum of the products of the random variable with their corresponding probabilities and is represented by capital E of X. Please remember these words, expected value and all these things. Here and there we will use in the formulas. Usefulness of theoretical distribution, not going into the types, already we have this. This is very, very, very important. Probability distribution. There are two types. One is Poisson distribution, second one is binomial, normal distribution. Binomial distribution. It is also known as binomial probability distribution. Is a widely used probability concerned with the discrete number variables and hence the distribution. A number of Swiss Jacob, some are called as Bernoulli distribution. The BD is the probability distribution, express the probability. Now, for example, when a coin is tossed, there are 12 probabilities, a head or tail. The tossing of a 5 coin, some fixed number of times, that is and the outcomes of such tosses can be represented by the BD. Now, here, understand this BD. P denoted by the success. The probability of event single trail, Q is the probability, is the fail. These P, Q are important. Q denotes for the failure, P for the success. Event occur exactly or times in and Bernoulli trails is given by P of R is equal to NCR into PR into Q. That you need to by heart the formula. This kind of distribution we called as a binomial. Conditions for Bernoulli process, VP. The experiment has two outcomes. And stability, independence, identical, and the mode trail, just go through it. Now, this is formula you need to by heart. I can't do anything. P of R is equal to NCR into P of R into Q power N minus R. You need to by heart this. I can't give you more explanation on this, but this is the thing. How it came, it's a big history, but mean or standard deviation of the baby is it's almost same like E of X is equal to X bar. The standard deviation BD is equal to MNP root of this. The variance of BD is the sigma square and PQ. Next, characteristics, I just go through it. Important on something. Binomial problem, just see this because just reading the fundamental expression binomial PQ is the procedure of finding out the probabilities of happening of exactly R events in N trials. The probability of occurrence of an event is a single known as this already we read it. Similar to this, this is A plus B whole square is formula is that the same formula will be equal to that. Means that if any event can take place either in form of P or Q with equal chances, then if the event is made happen, the probability of happening is equal to P square, Q square. Those are all 2P. Just now try. Tail, head, 1 by 2. What is the 1 by 2 means? 0.5. See, in 0 chance, first TT, QQ, Q square, TH, tail and head, they got one. Head and tail, they got one. Head and head, right? This is what? 1 chance, 0 chance. Because once you try thought, TT may not happen. If we make frequency distribution, it follows. Number of times 1. Number of times the 0, which neutrally we are not talking about head or tail. 0, 1, 2. But 0, 1 for the because we had 2 other chances 2 and again 1. This is the big formula that again you need to by heart to understand the probability sets. Binomial procedure. See, this formula has a lot of weightage. You need definitely by heart. The NCR is equal to n factorial by r factorial into n minus r practical. Pascal's triangles and everything. We can maybe we can see tomorrow. I think we all need to attend the other class. Okay, ma. Today just a probability I just gave briefly in there. Maybe tomorrow I'll try to finish the last unit because it's an hypothesis testing. It's also easy. Chances are like it looks like a kind of probability, but not really a probability. But tomorrow class also don't miss. Okay. Have a nice day, everybody. Okay, but do you have class again?